Hi guys, welcome to our YouTube channel. Please try and subscribe our YouTube channel for more videos. Okay, in our previous lectures we talk about electric current, Ohm's law and power. Today we are going to talk about equivalent resistance of series and parallel circuits. Okay, let's say what is series? Series circuit or series resistance, or let we say resistance in series. Okay, let's say resistance in series. When we say resistance in series, we mean that when we say series resistance is something in a straight line. Okay, when we say resistance in series, let's say we have a circuit, we have a circuit. This is our A and this is our B. Let's say we have R1 and this is our R2. Let's say this is our R3. Okay, when we said something is in series, we mean that something is in a straightforward. Let's say something is in a straight line. For instance, if we are to calculate the series, the resistance in series for this circuit, you can just say the R total. Say the R total is equals to R1 plus R2 plus R2. Okay, that is what? That is our total resistance. This is what our formula of resistance in series. Okay, put this in the back of your mind for any resistance in series. We are just talking about something in a straight line in one point. You see that the circuit is starting from here to here. It means that what? It's only one point. But when we say that a circuit, let's say we have a circuit, and here is a circuit, another circuit, but we have another circuit here. Here we have another circuit. So the difference between the first circuit and the second circuit is clear. What is the difference? The difference, the point between R1 and R2 is directing. But the point between, let's say this is R1, let's say R2, let's say R3, let's say R4, let's say this is our R5, this is our R6. The difference between this and this is just from R1 to R5 is not directly because we are having 2 points at the same time. We have R1, here R2, and R5. So therefore, the difference between resistance in series and resistance in parallel, they are clear. Okay, let's say resistance in parallel. Let's say resistance in parallel. Let's say we have a circuit. The circuit. Let's say we have another resistance. Okay, you can see the difference between this circuit and this circuit. They are not. There is no more difference because they are all parallel resistance, or let's say parallel series. Okay, let's say this we take it as R1, our R2, our R3, our R4, R5, and R6. To calculate our parallel resistance, we can just say because they are in parallel, they must have the same equal value. When we are having 12 voltage, but we are to put it in parallel resistance. So the voltage must be divided into two. We must have 6 and 6. Both voltage, both voltage will carry each value when you divide it by 2. Let's say we divide 12 voltage by 2. So in parallel resistance, all the circuits must have half of the voltage. Half of the voltage. Okay, let's say to calculate our parallel resistance, let's see 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. we have up to 5, 1 over R4 plus 1 over R5. Okay, this is how to calculate resistance in parallel. You can see that the difference between series and parallel is not much the same. Because if we are to calculate in series, something goes in straightforward. You can just add the value of your resistance. But if you are to calculate in parallel resistance, you are to divide what? 1 by the whole of the total resistance. Let's say we can calculate our total resistance like, let's say R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5, but what we are going to put it as inverse of 1. You can use this way and you can use the other way. All the way is the same. So let's see some examples under equivalent resistance. Okay, here are some examples under series and parallel. Okay, let's see the first example. Let's see here is A and here is B. Okay, let's recall our formula for resistance. Say R total is equals to R1 plus R2 R3 into up to Rn. Okay, from the first question says what? 10 ohm, 13 ohm, and 5 ohm. The questions is just showing us to all find the equivalent resistance of the circuit, the series and the parallel circuit. Okay, to calculate the first question, we can just recall our formula that R total is equal to, let's say this is our R1, this is our R2, and this is our R3. Okay, let's say R1, which is 10 ohm plus this is 13 plus 13 ohm, this is 5, which is R3, which is 5 ohm. Okay, our R total is equals to 10 plus 13, which is 23, 23 plus 5. Therefore, our R total is equals to 23 plus 5, which is 28 ohm. So that's our R total for question 1. Let's go to question 2. The same thing. Let's see phi 1. Let's see phi 2. Says that our R total is the same thing as the first question that I did. Let's say 5 plus 15 plus 15. Therefore, 15 plus 15 is 30 plus 5, 35 ohms. Okay, that's for series circuit. I hope this example is more convenient to you. Okay, let's move to resistance in parallel. So, to calculate resistance in parallel, let's say this is our A and this is our B. For our formula says 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 up to Rn. Okay, to start our calculation, we can just input, we can say we can find a resistance from this point to this point or from this point to this point because what they are indeterminate from we can't find either parallel or cycle. Okay, we can just start from the last because we are free to say that the resistance R4 to R5 they are in series. We can say that 100%, and we can say our R5 and R6 we can say they are also what in series. Okay, sorry, we not put the value. This is 20, the 20 ohm. Here is also 20 ohm, 10 ohm, and 5 ohm, and here also is 5 ohm. Okay, let's start our calculations. Okay, let's say from R4 to R5 we have a series cycle. Let's say our R total. In this way, we have to find our series because R4 and R5 and also R6 they are in series. Okay, let's just add them together with the three values. Let's say 10 plus 5 plus 5, which will give us 20 ohm. Okay, let us rewrite our circuit. Okay, we have calculate all. Let's see that here is our 10 ohm, 20 ohm, 10 ohm, 10 ohm. Okay, the R total we find between R4, R5, and R6 is what? Is 20. Okay, let's say 20 ohm. Sorry for the handwriting. Is 20 ohm. Okay, at this point, the next thing we have to do is to calculate either between the resistance, this resistance and this resistance, are they in parallel or in series? Okay, we can see that the resistance between the total resistance between R4 and R5 and R6 and R2 are in parallel. So we are to use our formula. Let's say that between R total is equal to 1 over R plus 1 over R2 up to Rn. Okay, let's say 1 over 10. This is our, let's say R1, let's say R2 plus 1 over 20. Okay, let's say the LCM between 20 and 10 is what? Is 20. Okay, let's say it's that when you say 10, let me explain it more. 0 times 0, 0, 0 times 1, 0, 2 times 0, 0, 2 times 1, which is 2, 2, 0, 0. Okay, let's say our LCM is 200. Okay, to calculate this, let's say 200 into 10. Let's say we have our calculator. When you say 200 into 10 is 20, 20 times 1, it will give you the same thing as 20 plus, let's say 200 into 20 times 1, it will also give you 10. Okay, let's say here we have 30 divided by 200. Okay, 1 over R total is equal to 30 over 200. Okay, we are looking for R. Okay, let's just cross multiply. R times 30, it will give you R 30 is equal to, well, let us say 30R times what? Times 200. Okay, let's divide both sides by 30. Divide both sides by 30. 30 cancel 30. Okay, let's say 200 divided by 30 to give us 6.66. Okay, let's round it up. We say 6.67 ohm. Okay, let's say the resistance between this and this is all equivalent. Is all equivalent to 6.67. 6, okay, let's say we have the resistance is 6.67 ohms. Okay, we have come to the end of this question mark. The one thing we have to do to complete the question is just to find the total resistance. Let's say that 10 plus 6.67 plus 20, let's say 20 plus 10, it will give us 30 plus 6.67 ohms. It will give us 36.67 ohms. So therefore, our total resistance is 36.67. Okay, let's say our R total for this question is 36.67 ohms. Okay, let's go to 5B. Okay, let's move to the next question. I can see that the next question will be so sweet of the rest of the question. Okay, from the method that we use to find the first one, we have to apply the same method in order to find the second value. Okay, let's start from this point. Okay, when we are starting from this point, between 10, this resistance and this resistance, they are what? They are in series. Okay, we know that resistance in series is equal to the total of the resistance, which is R1 plus R2. Therefore, let's say here is R1 and here is our R2. Okay, we have to just add them together to close them. Okay, therefore R is equals to 10 plus 10, and 10 plus 10 will give us 20. Okay, that's for this resistance. Okay, let us clean the resistance and just insert one resistance in order to understand. Okay, we have reduced the resistance. Okay, now we're having our 20 ohm. Okay, let's move to the next step. Between 20 ohm and 5 ohm, we have what? Parallel. We have parallel resistance. Okay, let's see 1 over R total is equal to, our formula for parallel, 1 over 5 plus 1 over 20. Okay, let's say our LCM is 20. Okay, let's see. Our LCM is 20. 20 into 5 is 4. 4 times 1 is 4. Plus 20 into 21. 1 times 1 is 1. Therefore, we have 5 over 20. Therefore, our R total is equal to, okay, over R, because it is in parallel, you can say it is equals to 5 over 20. If we cross multiply, we'll have 5R is equals to 20 divided by 5. By 5, 5 cancel 5, R is equals to, when you divide this, you are going to have 4 ohms. Okay, that's for this, for the resistance between 5 ohm and 20 ohm. Okay, let's clean it. Our final answer is 4. Okay, we have to put our 4 on this. Okay, the next question, between 4 and 5, we have what? We have a series. Okay, we are just to plus 4 plus 15, and it will give us 4 plus 15, it will give us 19. Okay, we are having 19. Okay, between 30, okay, between 30 and 19, we are having the same thing, we're having parallel resistance. Okay, let's print and say 1 over R total is equals to 1 over 30. 1 over 30 plus 1 over 19. 1 over R total is equals to, the LCM between 30 and 19, let's say 30 times. Okay, our LCM between 30 and 19 is 570. Okay, let's say our R total is equals to 570 into 30 will give you 19. 19 times 1 is 19. Okay, let's say 570, 19 plus 570 into 19. 19 into 19, it will give you 30, and 30 times 1 will also give you 30. So, therefore, 19 plus 30, we are going to have 49 over 570. Okay, 1 over R is equals to 49 over 570 cross multiply. Let's say we have 49R is equals to 570 divided both side by 49. 49, 49 cancel 49, and our R is equals to 570 over 49. Okay, 570 divided by 49. We are having 11.6. 11. Let's say R is equals to 11.6. Okay, that's for the parallel resistance between 30 and 19. Let's put 11.6. Okay, the same thing if we are to find the resistance between 25, 11, and 10, because we know that the resistance is in series, because the resistance passes through the resistance, through its resistance is just one point between them. Okay, let's say 25 plus 10 plus 11 is equals to 46.6. Okay, let's see here we are having 46.6 ohm. Okay, the same thing I feel our resistance is also in series 10 and 46.6, and also 10. We are going to add them together because it is also in series 46.6 plus 10 plus another 10, it will give us 66.6. It's so simple. 66.6. Okay, the same thing. Resistance between 66.6 and 20, it is also in series. Let's say 66.6 plus 20, it will give us 86.6 ohm. Okay, that's all for series. Now we have to find the parallel between 86.6 and the 10 ohm. Okay, let's say 1 over R to 10 is equals to 1 over 10, 1 over 10 plus 1 over 86.6 ohm. Okay, we have to find the LCM. If we say we have to find the LCM, let's say 86.6. If we have to find the LCM, we have to add all the denominators in order to find the LCM between them, the common factor. Let's say 86 plus 10, we're having 96.6. Okay, 96.6 into 10, it will give you 86. 86.6 plus 96.6 into 86.6, it will give you 10. Okay, 1 over R to 10. Okay, 86.6 plus 10, it will give you what? 96.6 divided by 96, 86.6 plus 10. Yeah, it is also 96.6 over 96.6, 1 over R. Let's take total, cross multiply, here is equal sign, here is our R. If we cross multiply, it will give us 96.6. R is equal to 96.6. Divide both sides by 96.6 over 96.6. Cancel. R is equal to 96.6 into 96.6. It will give you 1. Okay, therefore it's equal to 1 ohm. Okay, let's say the parallel resistance between this and this is 1. Okay, 1. Okay, let's say here the 1 ohm resistance and 5 ohm resistance, they are in series. We can just say 5 plus 1. So therefore 5 plus 1, it will give us 6 ohm. So now we have to find the parallel resistance between 30 and 6. Let's say 30, 1 over 30 and 1 here plus 1 over 6. Okay, let's see the same thing because all we are following the same thing. We are following the same method, either series and parallel, and this is equivalent resistance. The equivalent resistance just means to calculate the total resistance. Okay, let's say the LCM between 30 and 6. Let's say what? 30, let's multiply. If you are to find the LCM, you can multiply them. 30 times 6. Let's say we have 180. 180 into 30, 6. 180 into 6, it will give you 30, which is equal to 86 divided by 180. Okay, 1 over R is equal to 36 over 180. Cross multiply. 36 R is equal to 180. Divide both sides by 36. 36, 36, cancel 36. Therefore, let's say our R is equal to 180 divided by 36. Let's say divided by 36. So it was 5 ohm. Okay, it will give us 5 ohm. 5 ohm. Okay, we have come to the end of the question 2. between 10, 5, and another 10. The resistance 1, 2, 3, they are all in series. So therefore, the number 2, our total resistance is equal to the whole, the addition of the whole resistance. 15 plus 10 will give you 25 ohm. Okay, that's for the topic, the current under equivalent resistance and series current. I hope this video will be more helpful to you in order to find the equivalent resistance of any series or parallel resistance. Okay, please try and subscribe to our YouTube channel for more videos.